Alright, so we've been talking a lot about the disk method, which means that if we're rotating, that means I'm rotating up against an axis of rotation. So if I have a rotation, I have an area that I want to revolve around. Let's say in this case I'm going to revolve around the y-axis. It's flushed up against. We've talked about the washer method, and so that's when you have the area between two curves, and there's essentially, if I was going to rotate this guy around the y-axis, then I have a cutout of a hole that's located right here. I'm going to do it in green. And so this up here, this one is your disk. Okay, there's no hole in our volume. A washer has a hole, so that means you have to do kind of top minus bottom or left minus right, depending if you are dealing with X or Y. And so today we're going to talk about what do we do if we're revolving around not the X or Y axis. So let's say, like, what if I wanted to revolve around, I don't know, X equals 4 or Y equals 1. And so here are your steps to help you find the volume off the axis. First, I want you to draw the region. That is pretty standard. And so you need to decide if it's dx, which is a horizontal rotation, or dy, which is a vertical rotation. Determine if it is a disk, so that means, again, no space between the axis of revolution, or a washer, meaning there's a gap between the axis of revolution, aka similar to a donut, or if you want, or if we're cutting out, similar to like cutting out and having a basket. Number 4, determine the limits of integration. So find your a or b. That you might need to find where your two functions intersect, such as up here. So here you need to find where's the point of intersections. And so next you're going to draw in big R, and big R is, in this case, it's going to represent how far is the furthest function away from the axis of revolution. And so what I mean by that is, do this in blue. I want to revolve around X equals 4. And let's say I have an area that looks like a banana. Probably should do that in yellow. Alright, and so we're revolving around X equals 4. Your big R is going to be, notice I'll do blue as the outside function, and I'll do red as the inside function. Your big R is going to be, how far away is your blue function from your axis of revolution? So this is your big R. And so I'm going to be subtracting my blue function from X minus 4. So whatever my blue function is, I'm going to subtract that from 4, where my axis of revolution is. My little r is the inside function. How far is my inside function from the axis of revolution? So in this case, it's going to be r is going to be my f of x, my red function, minus my axis of revolution, which is still 4. And similar to when we're squaring and then multiplying by our coefficient, which is pi, we're going to be squaring each of these r's. So we're essentially creating a binomial. Okay. So big R is going to be top minus bottom, that's dx, or right minus left, that's your dy. And same is true for your lowercase r, is either going to be top minus bottom, which is dx, or left minus right. So the big R is the furthest distance, the little r is the smallest distance. All right, number 1, a region R, the first quadrant only, is enclosed by y equals x to the third and y equals the cube root of x. Find the volume of the solid obtained by revolving the region R about x equals -2. So let's get a picture first. I'll do it this way. We're only talking about the first quadrant. And so if I have y equals x cubed, that looks something like this. If I have the cube root of x, it looks something like that. And now we're rotating around about x equals -2. So I'll just pretend that this is where -2 is. Sorry, it's a little off the charts here. So we're rotating around x equals -2. Sorry about this, is not to scale. Just work with me. So since we're rotating around x equals -2, it is a vertical rotation. We're talking in terms of dy. And so that means I need to change all my variables for my x's not to be my independent variable. It needs to become my dependent variable. So we need to solve for x. So that means x is going to be equal to the cube root of y. And then for this guy, this means that x is going to be equal to y to the third. Okay. Again, we need to solve for y because we're doing a vertical rotation, and a vertical rotation is parallel to the y-axis, and that means we need to do things in terms of y. The next thing we need to find out is where in the world did these two intersect? Well, you probably can do a quick estimate. You know that they both go through the origin, just from the graph and knowing the two graphs. The other place they intersect is if I take the cube root of 1, I still get 1. If I cube 1, I also get 1. And so the other point of intersection is going to be 1. You can set them equal to each other, so I could have set the cube root of y equal to y cubed both sides, so I would get y to the third is equal to y to the ninth, and then factor, but I figured that would take way too much time, you would get overwhelmed, and you would just trust me that they intersected 0 and 1, and that would make sense to you. If you want me to do that, I can show you on Friday. Alright, so now that we have our points of intersection, we know that we're going to be doing pi. We're going from 0 to 1. And so now we need to get our large radius and our small radius. Well, the one that's furthest for my area, the one that's furthest is my red function. And so my capital R, I'm going to do left minus right. So I'm going to do my my right function, which is the cube root of y. I'm going to do that to the 1/3 minus, and so that distance, I'm going from this distance to this distance. So that's going to be my red function minus my -2, my axis of rotation. And so you'll notice a negative and negative. Hopefully you can figure out it's going to be a positive. And it's okay if you want to write y to the 1/3 plus 2. My lowercase r is going to be the distance between my blue function and my axis of rotation. So that's the blue function is the one that is closest to my axis of rotation. So y is going to equal, in this case, y to the third. And again, I'm going to subtract, so I'm going from the distance from the blue function to my axis of rotation, which is my yellow function. And so it'll be, again, minus -2, and then once again, you know a negative and negative becomes a positive. And so when I'm doing these, I'm going, because this is a washer, notice that we're going to create a little bit, there's a hole here. That's empty white space, and it's not going to be a hole filled in solid it's going to look something like have like a cone on the inside, like a bowl with a cone on the inside. There's empty space in there, so we're dealing with a washer. That means I need to subtract my r, my capital R minus my lowercase r. And so our formula is our r squared for a washer is r squared minus lowercase r squared. In this case, we're dealing with dy. So now we can go ahead and substitute in. So I have pi, we're going from 0 to 1. My r squared is y to the 1/3 plus 2, and we're going to square that. And we're going to subtract that by my lowercase r, which is y to the 3rd plus 2. And this is all in terms of dy. So now let's go ahead and multiply our binomials out. There's my coefficient. I'm going from 0 to 1. And so I'm going to use a couple quick tricks. When I have a binomial and I'm squaring it, that means I square the first term, square the second term, and then multiply the two terms together and times it by 2, and that gives me my formula. So similar if I had x squared, that's not what I want, x plus 2 squared. I square both of them, so I have an x squared. I square 2, and it's 4. That's not the right stroke, 4. And then I multiply them together and times it by 2, so we're talking about 2x. So I'm going to use that same idea. Hopefully I can fit everything. All right, so I'm going to multiply. So I'm going to square 1/3, so that becomes y to the 2/3. I'm going to square 2, which is 4. And then I'm going to multiply 1/3 times 2, so that's 2 times 1/3, and then I'm going to multiply by 2 again. So we have 4 y to the 1/3. And I'm going to subtract it. Sorry, I ran out of room. From, again, I'm going to square. I forgot my squared here. I'm going to square my y to the 3rd, so that'll be y to the 3rd times y to the 3rd. That's y to the 6th. Square 2, which is 4. And then I multiply y to the 3rd times 2 is 2y to the 3rd times 2 again is 4y to the 3rd. And this is all times dy. So now I'm going to come down here. So now we have pi going from 0 to 1 of y to the 2/3 plus 4y to the 1/3 plus 4, and now I'm going to distribute my negative, minus y to the 6th minus 4y to the 3rd minus 4. So I do have some good news. I know that's a lot of terms. Your 4's are going to cancel. So that makes things a little bit nicer. So now let's go ahead and take our antiderivative. So y to the 2/3 plus 3/3 is 5/3. So this is 3/5. Plus 4 times 1/3 plus 3/3 is 4/3. So we have y to the 4/3 times 3 over 4. That's nice because these two will cancel. Minus y to the 7th divided by 7. Minus 4y to the 4th divided by 4. Again, that's nice because that will cancel. And we're evaluating that from 0 to 1. So at this point, once you plug in, you're going to have 3/5, because it's all 1, plus 3 minus a 7th minus 1. When we simplify that, we get oops, times pi, forgot my times pi here. So I'm going to get pi times 86 over 35.